This video is a simulation of the use of a vernier caliper for a particular case of a machine block. It first measures the outside dimension on a projection coming out of the block and then measures the inside diameter of a hole. We show a few repetitions of a similar measurement for hole number 2 and hole number 3. And you can see that the readings can also be picked off if we zoom on them. And this simulation is useful to check whether the vernier caliper will foul with the block or not. And you can see the screw on the vernier caliper getting very close to the surface. This simulation shows the measurement of the width of a slot that's been machined. And one can also check the ingress-egress of the vernier instrument itself. And accordingly one can make the design or the drawing. Here the depth checking is being done on a hole that's closed at the bottom. I hope this presentation was an introduction and was useful to you. Thank you and bye-bye.
Okay, I'm going to go over how to read vernier caliper. Here's our caliper, and the first thing we need is a hint about what all of these numbers mean, and the hint is going to be given to us on the instrument itself. Here it's telling us that it's reading to the 1/1000th of an inch. If we get an overview of it here, we see that this is 0, 1 inch, 2 inch, 3 inches. We should be able to kind of recognize that from the instrument itself, see what's about an inch, and that should be marked on there. Then what we're actually reading from is this index, where the bottom scale here reads 0. This part will slide back and forth on the instrument, and what we do is we read from where the index is. So here's 0 inches and here's 1 inch, and you see it's divided up into 10 equal parts, so these are tenths of an inch. So this is 0.1, 0.2, 0.3. So our answer here, we already know it's less than an inch, so it's going to be 0.4 and then something. Okay, we still have 2 more decimal places to go, and that's going to come from how far it is between the 4 and the 5. Now notice that between the 4 and the 5 on here, this is 0.4 and 0.5, there is a divider in the middle, so that divider is half of this. So if the distance from 4 to 5 is 0.1, this is 0.05. This is divided into 50 thousandths of an inch. Here they are down here, but the trouble is, where do you read on this scale? Well, let's look. It's toward the back part of this. It's toward the halfway mark. So it's going to be toward the end of this scale. And what we're looking for on here is where the tick marks line up exactly. And you can see that they're getting closer in here, closer, and it looks like right there they're lined up, and that's at 40, 41, 42, at 43. So the reading is 43. And notice we're less than the halfway mark here. So our answer is 3.443. Like that. Okay, so let's examine it again. It's 0.4, and then we see that we're toward the end of this mark, so we'll go to the end of our vernier scale and look for where it starts to line up, and it lines up at 40, 41, 42, 43. Okay. Now, what happens if we're on the other side of that halfway mark? Let's move our caliper, let's open it up, let's have another reading here. Okay, there we are, we're beyond that. So our index says that we're still less than an inch between 0 and 1, and now we're between 6 and 7, but we're beyond the halfway mark. So it's going to be 0.6 is our first decimal place. Now our next 2 decimal places, we're going to take 0.65, because this is beyond the halfway mark, and this is 0.5, so it's 0.65, and to that we're going to add what the vernier scale reads, and it's right in the middle of this small, right between these 2 tick marks, so it's going to be right in the middle of our vernier scale. and there it looks like it's right there at the 25. So we'll add to the 6, 5, 25. Our answer will be 0.675. Now where did that come from? 0.6, because these are the tenths place. 1, 2, 3, 0.5, 0.6. So it's between 0.6 and 0.7. It's greater than 0.65, and this vernier scale reads only 50 thousandths. So we add the reading on this scale to what we read directly off of this. So we read 0.65 off of this, and we add 0.25 to that from this vernier scale. Don't worry about the numbers up here, just worry about where the lines meet up. So for this one it's 0.65 plus 0.025 equals 0.675.
The micrometer is built around a frame with a fixed anvil to the left and a numbered scale sleeve to the right. The measured value is the distance between the fixed anvil face and the spindle face that moves when turning the thimble. It's good practice to clean the measuring faces before using. Gently close the micrometer on a clean piece of paper, then slowly pull it out. To make a measurement, hold the part with your left hand and position against the anvil face. Then hold the micrometer with your right hand and turn the thimble counterclockwise until the spindle face contacts the part. Reliable repeatability depends on applying uniform pressure from one measurement to the next. Micrometers have either friction thimble or ratchet stop speeder to help ensure uniform pressure. When measuring a stationary or fixtured part, make note of your measurement before removing the micrometer if possible. If your view is obstructed, lock the spindle by turning the lock nut counterclockwise. Then hold the micrometer by its frame, carefully slide it off the work, and note your measurement before unlocking. Now that you know the basics.
Okay, how to take reading. So the reading of the micrometer is equal to the readings of the main scale. This is the main scale, plus the readings of the thimble scale. This is the thimble scale. This is the main scale. This is the thimble scale. So the reading is equal to the main scale plus the thimble scale. For example, this one. The readings of the main scale, each one is 1 mm, 0, 1, 2, 3, 4, 5, 5 mm. But then here, in the middle of these two, we have another scale here, right? Okay, then this will be the 0.5 mm. So 0, 0.5, 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5, 5. So here, this one, the readings of the main scale is 5, 5.5. Okay, so the readings of the main scale is 5.5. mm, this is an mm. Just now vernier scale is in cm, but this one is an mm. Okay, and then the readings of the thimble scale, we read from here. This line is to see which line is coincide with this the straight line in the main scale. Okay, this 30, right? Okay, it coincide with this straight line in the main scale. So the reading will be 30. Okay, 30. But 30 is not 30 mm. It's 0.30 mm. Each one represents 0.01 mm. So 30 means 0.30 mm. So with the reading of the main scale 5.5 and the readings of the thimble scale 0.3. So therefore the correct reading will be 5.5 plus 0.3. 5.5 plus 0.3, it becomes 5.8 mm. Okay, so that is how we take reading from